Okay guys, I'm going to have a slight change of focus here. Something that most of you know I've been talking about, and what originally got me into this big search for truth was a search for what we call the FE device. Yes. And a few years back I made a proof of concept, which I want to show you, and then we'll get to the latest incarnation. Alright? What I've got right here sitting on my kitchen table is something I built a few years ago. I'm going to bring it up and try and get the picture on this. Alright, now, let's see. What this basically is there's a big wheel here. These are 1.5" neodymium magnets, and they're in about 25 layers of Lexan, all drilled individually, epoxied together, and I made myself a rotor. Okay. These windings right here actually power it. They're bipolar, which means there's actually 2 wires wrapped around, so there's actually 2 different circuits in these. And actually these are the back ones. We'll turn it around and you can see there's another set on the other side. And these are actually the drives for it. And what we get out of these, that's a whole lot of copper. I can tell you that right now. Okay? Now, the way the principle works is that what we put into it, we get back out of it. Alright? That's the whole idea. I had read once online, this is based roughly on an Adams motor, although they only use 4 magnets, and they usually spread out lengthwise. I made a few modifications, and I'll show you some of them. Now, what these magnets get, what I had learned online is that these magnets are actually pulled towards the bolt in the middle of each coil. Okay? And as it comes up to it, it gets sucked in, and then with just a little pulse of electricity in the opposite direction, it actually frees up the drag so it goes to the next one. And you have to turn the electricity on and off just so it can go past. So I can give you a basic example. Once you set the thing in motion, it just runs. Okay? Now, some of the things that are very critical on this is that, like I said, the electricity that goes in, you get back out. The way that's done is with capacitors. I've got quite a few of them over here. And let's see. And we have a timing device, which I'll show you for the drive motors, or the drive coils. Now, the way that it was originally done is that there was a flat wheel with a brush, and it was star-shaped, coming to a point. What I did on mine, I don't know if we can see this, I took a piece of 3/4 copper pipe, or basically a fitting that you would normally put them together, and I cut out 8 notches, and then brought them down into a very, very tight V shape. I don't know if you can get a picture of them there. But it's just epoxy and copper. Okay? Now the basic idea is that we've got one little wheel on the inside instead of brushes, a lot less resistance that way, and then this one out here, and it just has the wire, and it holds against that copper pipe. Now, I had used the bearings instead of brushes because they don't wear and they don't offer as much resistance. Resistance is key, or the lack thereof. Okay? Now, the power goes into one set of coils, and then it's actually retrieved out of the other set of coils, in the drive coils. They get stored in a series of capacitors, and since it's DC, or since what comes out is actually AC, I should say, it goes through a bridge rectifier, which is basically 4 diodes, and you're going to see there's one set of diodes down here. This is actually done in a couple of times. There's another set. Looking around. This might be it. Anyway, and then it's stored in capacitors. Now, what's really neat about this is that when you put, let's say, 12 volts in, you actually get 24 volts back out. But not a lot of current, but with each pulse it builds up and it stores in the capacitor. And then for real brilliance, most of the other vectors that I was working with on this was trying to use electronic circuitry to create a timer to return this stored electricity back to the battery. And what I did is these are actually gears out of like the motor from a Barbie Jeep, and if you're familiar with Power Wheels. I use them for a lot of experiments. So what happens is that when it's going, we have copper contacts right here, okay? And these actually capture the electricity that builds up in the capacitor. And as it builds up, you have to time it so when it gets to about twice the power, yes, these things do take adjusting and cleaning. Okay, now you'll see the sparks every time, right? And it makes a wicked spark. That spark is the power that's generated or returned out of the coils, and it's dumped back into the battery. Now, on the other side, we've got just pure generator coils. These work a little bit differently, but they don't supply any power. All they do is they're just pure generator. As the magnets fly by, these draw electricity from that. And the same principle, it goes through another set of capacitors. When they charge up, this one goes a little slower. It's geared down. And this will make some big sparks also. Now, what we wind up with, now I haven't run this much in a while. It's a little noisy, as you can hear. But when I first put this together a couple years ago, I was able to run it, you know, by putting a voltmeter on it and making sure I had 12 volts, and it would maintain its voltage. What I did have to do, though, is that every day I had to clean all the soot off the contacts. The bearings needed to be lubricated, otherwise they would seize. Not just the ones on the shaft, but particularly the ones that I've got the electricity running through. Plus, the armature itself would just turn black. Like black, sooty black. And I'd need to put like some vegetable oil on them, clean it off. And what I did is I just maintained it every day. It sat on a shelf and it ran all day, all night, for a couple of months. After a couple of months, the batteries had not lost any electricity at all. It just kept on going. So the proof of principle is it doesn't take electricity to run a motor. You can get most of that back and maintain your batteries. There's been a lot of experimenters that have proven this, but you know, I wanted to take internet folklore and build myself a version of it. Now here's the thing. My daughter observed that it doesn't really do anything. And she's right, it doesn't. It'll run, it'll spark, it'll just keep going. If you take good care of it and keep all the contacts clean, it keeps going. Now some of the guys that have tried this with electronics have had limited help, limited success. But the problem is when you up the voltage, which actually creates more of the effect, and you can actually get more, we'll call it, you know, free energy, these start taking a really big beating. You wind up chewing up the copper, chewing up the brushes, you know, it starts turning into an arc show. I've already had to change the wires and contacts on the other side a couple of times because eventually they just melt away from all that sparking. And I've also tried using photoelectric cells or magnetic, like inductors, like the kind that you would use to for an alarm system on a door, you know, where it knows if you've broken the electronic field. They don't last long either, though. Doesn't seem to be how I work them. They'll run for a day and they stop working. So this turned into the most reliable setup I could find, and by far the most energy efficient. But basically this proof of concept works, okay? So then we're going to go on to the next version of this. which is something I started last year. Now, yeah, I got sidetracked, I'll admit that. But inside here is the big wheel with the neodymium magnet powder that I was talking about. Down here we got a basically another one of those Barbie Jeep motors. In fact, it's the motor from the transmission that the other one's working, because everything gets recycled. Now, I had originally built this with a gear and a gear, which actually worked quite well, but it screamed. It made so much noise you couldn't hear yourself think. I tried doing a belt drive, okay, which works a lot better. It doesn't make any noise, but it slips a little. It doesn't take the torque, and these belts are kind of, they tear themselves up over time. So I've got a little engineering issue there. I want to try to get a tooth belt, maybe off the drive of a beater bar in a vacuum cleaner with the right pulleys. I'm sure I can find it in the garbage somewhere. Okay, down here, I've got the variable speed, which is basically just a trigger from a power drill, and a little nut, which will adjust the power going into it so I can tune it. Okay, getting everything at the right frequency is supposedly very important. Now all these holes up here are for another set of neodymium magnets. I've got 2 inches, and they are right here, and they're going to go in every hole. I had some of them taped over. I was doing experiments. I noticed that this wheel spins a lot easier when there's something in every hole. But then you got to tune it. This wheel, if I slow it down, it's not all that terribly stiff. And unless you get all the magnets exactly spaced right on each side, it will pull the wheel to one side or the other. So it takes a little bit of fine-tuning there. Basically, what I want to do, I didn't leave quite enough room for as many coils as I want, and they don't go in all the way. I'm going to reconfigure this with a bigger hole and a bigger inset, so I can put the coil the whole length of the magnet, and then leave another room for an outer coil, an inner and an outer. And I plan on being able to run this at much higher voltages. Still a work in progress. I've got a lot of room around it. Back here, just like the other one, I got its own built-in battery supply. There is actually an online competition for the first person that comes up with one of these that actually works. You can plug a house into it or something substantial, and it creates more electricity than you put into it. Well, this is what I'm putting into it, and the real beauty will be closing the loop. You know, can I actually get this to put out something and then bring it back to 12 volts DC and power the little motor and keep the wheel going? That'll be huge. If there's anything left over to run lights, bulbs, and things like that, then I'm really doing it, okay? These things take a lot of time. They really do. There's just so many parts involved, and they've all got to be made or scavenged. And I know you've been asking about it, and just wanted to show you what I've been doing. And then want to explain the 2 years of theory that I've been trying to absorb on how to make this work. But I've learned a lot in the last year, and I'm going to take another crack at this because I think there's a lot less guesswork involved in it now. I've got a fairly clear idea of where I'm going with this. Anyway. So, a little less time as the amateur philosopher, a little more time as the mad scientist. And I will get to the bottom of that thing one way or the other. Okay, I've got a whole bunch of toys to play with it. Anyway, we're coming up on the time limit, and pretty much did what I wanted to do with this video. So, have a great day, and I'll see you on Dots. Good night.